Good morning, good afternoon, and good evening, wherever you're joining us from. Thanks for attending our webinar today on getting started with observability on Kubernetes. We are recording the session today, and everyone who registered will receive a link to the on-demand recording for later reference or to share with a colleague. I'm Heidi Gilmore of StackState, and with me today are expert presenters will be Ricardo Santos, Director of Sales Engineering, and Andreas Prins, VP of Product Management. So let's just go through a quick overview of what we're going to cover today. We'll start with a brief overview on StackState. Many of you joining today may not be super familiar with who we are and what we do, obviously connected to observability. We'll then go through some foundational information before we jump into actually getting started with observability. The first section will cover 5 challenges in cloud transformation, and then 6 recommendations to consider, and not too shabby when Andreas gives us more recommendations than there are challenges. So thanks for that, Andreas. After that, we'll transition to a short demo from Ricardo on Kubernetes infrastructure, and he will cover a StackState product overview and demo. We'll then close with some Q&A and some suggested additional resources for you. So StackState, this is a group of StackState employees, and we were celebrating making zero downtime a reality for our customers. We are solely focused on observability and AI ops. We have a presence in the US and Europe, and we are totally customer obsessed. This fanatical devotion to customers is reflected in our reviews on G2. Finally, we've had a lot of analyst recognition for the unique approach we have taken to solving the observability challenge. And at its heart, observability is a data problem. You'll hear about that today. And we've tackled it in a very different way from anyone else. Finally, along the bottom of the screen here, you see some of our customer logos. They cover many different industries, but the common theme is they are enterprise organizations with dynamic IT environments where change is a constant and the need for observability is a critical one. Let's now transition to our program for today. And Andreas, let's go over to you for a walkthrough of the 5 challenges and 6 recommendations.
Thanks, Heidi, for this introduction on StackState. And it's really cool to see, because earlier this week on Tuesday, we also had a webinar together with a few other people and an extensive panel discussion. And I'm super delighted that some of the people who tuned in on Tuesday are actually now coming in. And earlier this week, some of the people asked, how do I realize, or how do I set up causal observability for my organization? And if that was one of your questions while you were in the previous one, we're definitely going to answer and make it super visible today on how we approach that. So really nice to have 2 webinars in 1 week and actually see a couple of you in the second webinar. If you might wonder, hey, what was presented? Most likely someone will share the recording in the chat. It was all about how can I actually mature my observability practice. And in the panel discussion and in some of the theory we shared, we're laying out a growth model for you to ultimately strive for zero downtime organization. So please watch that recording. And well, again, welcome to everyone. And in particular, if you're joining here the second time, super nice to make that happen. All right, so what is really interesting is if we talk about observability or the entire monitoring and maturing the practice, we actually spot a couple challenges, in particular when companies accelerate into cloud and container and Kubernetes. And we thought it might be nice to share these challenges just to show that you're not the only one struggling or facing these issues, as well as come up with a couple of recommendations that we see happening at our customers. And that will come back and become really alive in the demo that Ricardo will give in a bit. And the first thing that we see happening in the company is that many teams become really autonomous and many teams start to deliver faster and faster their applications and really focus on the microservices and the cloud components they own and they develop. But what they're lacking is a holistic picture. So the enterprise itself is lacking a holistic picture really to bring all the components together. And what we see is that companies who go really fast in the implementation and maturing their observability kind of at the team scale, they ultimately um, step into the challenge or into the pitfall that when really an outage is happening in other teams, that they find it really hard to pinpoint the issue. And you might be familiar with this, and a little later in the demo, we will demonstrate how across-team issues can be solved if you set up that more holistic type of observability. But let's go there in a bit. The other one, which we should be honest about, is that although many of our customers and many larger enterprises and smaller companies are moving to the cloud, we all know that under the hood, it will remain a kind of a mixture of different technologies. So you can say, hey, how can I apply kind of modern development practices on the islands of innovation that go really fast, and at the same time not lose the connection towards the teams that are benefiting from technology that's a bit older, more robust, more stable, and living there for a long time. And really the issue is that the tools sometimes disconnect. So there are other tools being used to observe the modern stack than there are to observe or monitor the more existing traditional type of technology. And a challenge you might face is how do you bring actually these two different technology silos together, and how do you build a holistic understanding again that helps you to really understand what's going on in your environment and in your company. So that might be a second challenge that you're facing. And bringing the question then to you and to us is, how do we going to solve that? But more about that in a little bit. The other challenge, and for the people who tuned in earlier this week on Tuesday, we touched upon this topic as well, is we do see that many engineering teams have had a real fast acceleration of how they develop their software, how they build, how they implement test automation and even pipeline automation to push software out to production really fast. But there's so many practices and so many movements and new technology coming towards them that they might face sometime the stretch really into production to also start observing how the applications behave. There has been a lot of practices being shift left, and observability is yet the other one. Although, if you might face this, the real challenge is that you actually are shipping faster without truly understanding how the components are behaving. And they might be more stable because the cloud brings a ton of benefits to increase uptime. You might be unaware, for example, about issues like performance degradation. How is it really? It's up, yes, certainly, but how is it behaving and how it's operating? So that is something to take into account, because understanding what's happening in production with your services, with the components you're developing, is a crucial factor to be aware of. So the question is probably how do you bring also this practice of observability back to your engineering teams, your DevOps teams, so they really become holistic end to end. A lack of understanding how it's operating in production might cause you some issues. And then, and this is not uncommon, is that there's really a skill retention challenge. And you might see that as well. You're happy that you can develop your software. You're happy that you can maintain kind of the most crucial people that know the entire landscape, the entire IT environment, who know how to do the foundations. But really, if it comes about innovating, bringing in people who not only know Kubernetes, modern frameworks, cloud and container tools to deploy, set up a service mesh and whatnot, you also need to bring in people that know the newer practices of observability or open telemetry, just to call out a few that are really dominant now in the observability market. And really a challenge you might face is, there's such a churn going on. How do I maintain the people Or, and that's how we like to see that question being asked, how can the tooling, the observability tooling in our case, how can that help you and your team to actually capture the knowledge of the experts so they can start focusing on training, teaching people who come in new or the more juniors in the team. But maintaining the skills, both from the technology, the cloud and container technology, as well as the tools you use, the observability tools, the CI/CD pipelines, yeah, you might really see that as a challenge. And that's what will demonstrate how tooling can help you to solve that as well. All right, and then the fifth one, and it's probably obvious and it's really visible everywhere in the industry, is with the speed of automation and with the ability to push much more often your software into production, more autonomous team working on smaller components, how do you stay compliant? How do you make sure that containers who are pushed into production are indeed coming from your curated container repository? How do you make sure that the pipeline that's pushing out the code to production is indeed the pipeline that has the 4i principle, the code scanning, the unit testing coverage and whatnot? And besides these couple examples, there are tons of other potential compliancy checks that you need to fulfill. And we know that that might be a challenge as well, in particular if you start adopting cloud and container technology where we are talking about today. So yeah, again, be aware. How can you make sure that, for example, a central SRE team can take a look at this and bring that holistic understanding to the company, not only in checking the boxes, but also in using automation solutions to get you there. But before I go too much in the recommendations, let's wrap up this this section. We've seen that all of these movements that are going on, the acceleration and whatnot, also bring in a ton more components and a ton more data that you actually need to observe. So the interesting question is, how do you also bring all the data together and ultimately, start observing your entire landscape from a bigger picture? And for you who know StackState a little better, that is what we believe really one of the issues we need to tackle. So let's go into the recommendations and then we move into the demo. All right. The first one I would recommend you to consider, and we see a lot of companies really succeeding there in the last 1.5 to 3 years, for a few of them really lately, is to sit around the table and really understand what are the needs of my teams and how do I set up a SRE practice that is helpful for my organization. And probably you know that there are many flavors on setting up a central team or on setting up the observability practice or the SRE practice. I'm mixing it a little bit here. That there are multiple ways to do that. Some companies choose to set up more local teams where they believe that every DevOps team themselves need to have the knowledge and need to execute these practices themselves. Others realize due to a skill shortage or skilled engineer shortage in this particular observability practice that they actually need to set up a team who is more in a central place. And then we see two flavors. One of them are the Tiger team who go in, help out the DevOps team for a week or two or a month or two, and then move to the next. And with that, they bring the practice to the team and help them to uplift the skills. Other companies and other of our customers, they have it more in a central place. And they know that if they have that centrally and they coach it, right? So one SRE team with 6 members coaching out 10 DevOps teams, that is a fruitful model for them to scale the practice. Ultimately, defining the responsibilities for each of these flavors is super important. And that's also my second recommendation, or our second recommendation that we would like to make. Because if we start talking about observing the more modern landscape, we talk about service level objectives and indicators. And that is not something that you start implementing in an observability or a monitoring tool. That is a more fundamental question. Who is actually responsible for the different activities and things that are going on? And even in our company, as you can imagine, running a SaaS product, we have a team that is primarily focused on the platform. And then there's another team, or actually all of our development teams, who are responsible for the capabilities that run on the platform, right? So there you see that you need to articulate who is responsible for what to make sure that the teams understand the full responsibility and can then, in the tools they have, gather the right metrics and set up the right mitigations to really control that. And without implementing a single dashboard or a single monitoring tool, please have that conversation. That is really fruitful and helpful to understand what needs to happen there. The third one is a little bit going back to the data problem that I mentioned. If you start moving into the cloud and container space, you just get a ton more components you need to observe. And with a ton more components, you also get a load of data into your data lake or into your monitoring and observability tools. And if you don't bring that together in the right manner, it becomes really, really hard to understand actually how the data is all related together. And what we believe is that engineering teams who want to understand the big picture, they should actually elevate to the next level and really build a kind of a business layer, a business understanding of the components that they're looking at. And in the demo, we'll demonstrate you how observing the more technical components in your landscape can be connected with the bigger picture. And that in particular is helpful because then you can also really see at one glance what's going on in my entire stack. So building a more business-oriented layer on top of your tech, that might be a really good recommendation for you to move away from all the noise and really focus on what matters, besides setting the clear goals. All right. The fourth one, what I believe needs to happen as well, is really grow your practice of observability. And clearly, if you didn't join on Tuesday, what's the recommendation here? But this is one of the topics where we believe that it's not only the tools that evolve, but also the mentality and how you take a look at observability. Are you able to start instrumenting your code with, for example, OpenTelemetry, using tools like Jaeger to really start observing it from the inside out? What is happening in my function, and can I spit out data, instrument my code to push data into my observability tools to really understand what's going on? And this can be a direction that will help you to build a more robust system of observability. So that would be my other recommendation. What are the supportive technologies you can use to build this understanding? And then the fifth one should be about building your control framework. And I'm having a background in banking, so I'm super familiar to how hard it can be. But really what I believe is that the solution lies in the automation. First of all, in the simplification of your control framework, but then second, implementing the right CI/CD pipelines, the right container registries, and really enable your teams to do as much as automated. And why does this then show up in an observability presentation? Well, because it is also important to really track what is being pushed to production, what are the changes in production, what are the pipelines that pushed out the code to production, and start tracking it in this way. So observability plays a really important role in understanding what's actually out there, where do the containers come from, and what not. So redefining a non-intrusive way of building a control framework might be helpful if you are in this cloud and container space. All right. And then last but not least, and I touched upon this already a little bit, is we think that teams who have optimized for their own needs should use their own tools. Whether or not it's a build tool, it's a CI/CD, a test tool, or whether or not it's a monitoring tool or observability tool that takes a look at their own components. Don't change it. But super important is, are there other ways to really bring all the data and ultimately all the teams and the components together? And we think that through the help of causal observability, or what we'll see in a bit in the demo, we believe that this might be a really good way to leave the teams autonomous and at the same time bring that together and help the teams move forward. And with that, I'm handing over to, no, I'm actually not handing over. There are two more slides. Sorry for that. Let's take a close look. So, two more statements to summarize. as mentioned, observability has become a data problem because there's so many components creating so much data. How do you keep track of it? And we think, and that's what we will see, is that you need to have a whole new thinking on how to bring the components together and set clear goals to start tracking this. And secondly, if your team starts shipping more often and really start pushing out more frequently new versions of your containers and of your components and of your software, we believe that topology can be the anchor to bring this all together and start correlating all the data, the metrics, the traces, the events to this entire topology. And if you've never heard about topology, that's what we'll show you in the demo. And with this, I'm handing over to Ricardo, who will give us a demo. But before he's going there, a brief product introduction.
Can everybody see my screen?
Excellent.
Awesome. So today's topic really is about Kubernetes and how StackState also can monitor an environment like Kubernetes and deliver a lot of value in figuring out where issues are coming from. Before I dive into the demo, I'd like to level set and kind of go through a brief introduction of StackState as a whole and how the solution operates and how it delivers value generically, and also what is the problem that it aims to solve. So environments in IT organizations are really complex. You end up having a ton of business applications that are managed by different teams, and these business applications then in turn have series of monitoring tools on top, infrastructure monitoring, APM, and log monitoring. And each one of those tools then stores data in a very different environment. So this data ends up being stored in a segregated way. So the infrastructure data doesn't connect to APM or to log monitoring or so on and so on. And then the end result of this is that you end up having a series of teams with a series of dashboards with very different tools. And every time there's an issue, if this issue is originating from an environment that has several monitoring tools, then you end up having things like alerts storms, where each one of these tools sends one or more alerts to different teams, and different people are then looking at different dashboards and so on. Now, it's often said that observability is all about having a holistic view of an environment, so not having any gaps. But the reality is, even if you have everything covered, but you have it covered with different tools, you end up not really having observability. Even though all the data is there, you still have the issue of different data, different symptomatic alerts for same root causes and so on. So really the characteristics of this problem are that you end up having a severe lack of context of the data and correlation. You end up having technology silos and team silos where everyone is looking at different dashboards for different tools. Alert storms as well, where each one of the tools will send one or more alerts for the same root cause, which obviously is down to the lack of cross-domain visibility. It's also quite manually intensive to figure out, where in the data should I be looking at, which dashboards should I be seeing. You end up in the same scenario of war rooms where multiple people from multiple teams are troubleshooting effectively the same issue, because fundamentally the primary challenge there is figuring out where is the issue coming from. So really the solution for this is having something on top of all of this data that unifies all of this data and brings it together in a true uniform and unified view as well, a true holistic view of all of your environment with all of the data that's being captured already. Now, really StackState has topology at its core. So the way that StackState solves the observability challenge is by having a holistic topology of everything that you've got in an environment where data comes from multiple tools. So you have, for example, things like ServiceNow, Kubernetes, StackState as well, VMware, that feed you topology data. So then on top of the topology data, we bring in telemetry and tracing data to augment that topology. So that then ends up creating a topology that allows us to figure out, well, exactly how does my environment look like at the moment, and where do I have issues coming from? Now, another really important component is the ability to go back in time and figure out, well, what changed in my environment that led to the current condition, the current issue that I have as well. So not only we have all of this data coming together, but we go back in time in a way that you can figure out what changed in an environment that caused an issue. And I'll dive in a bit deeper on this in a while as well. Now, the big change here, the big value add is in the life cycle of an incident from the change that originated it, the typical observability technology is only going to start looking at an incident from when the anomaly was triggered. But because StackState has the ability to go back in time, we actually go back and figure out, well, what actually changed that then triggered my system to go into a critical state as well, into a critical health state. Now, at the center, we have what we call the 4T data model. Now, the first T of those 4 Ts is topology, really, and this is the key to having a true understanding of how your environment looks like. So topology, for us, as I mentioned before, we capture topology data from all sorts of solutions on the market. So we have a series of integrations that are out of the box, really easy to set up. And in today's demo, I'll cover the Kubernetes one because it's more relevant. But really, on top of all of these out-of-the-box integrations, we also have the ability, which is what these pluses at the bottom represent, we have the ability to very easily and quickly ingest custom data. So when we're looking at an environment that has all sorts of different tools and potentially gaps as well, it's very easy to extend the solution. It's a very open platform. It's very easy to extend it to then receive data from systems that are not monitored in any type of format. We have, for example, spreadsheet here. We've got Dynatrace, an APM tool, AWS environment, Kubernetes. We've got GitLab, Jenkins as well, so deployment tools. All of those tools have very rich data that, with the right context and correlated with the other data, will deliver a lot of value. So the way that this then works is each type of solution or each solution has its own vision of topology. So we look for elements that are similar, that are the same element in different topologies, and we really bring these different topologies under one single topology. The rules that decide if an element is the same to unite it in the final topology, they're also highly customizable. So it's really easy to, if you have one format or one standard of host names in an environment and a different one in a second environment, it's really easy to make those two match and to write rules that figure out what are the differences in naming conventions, for example. And this is really the end result of having a very large environment that has different monitoring tools, different CRM tools, different CMDB tools as well, and all of that data coming together into one place. The second T really is telemetry, and this is when we start to then pick up all of those golden signals, that rich data that tells us how an environment is doing. And again, we have a lot of integrations out of the box that connect to a series of systems, but also it's very easy to then send your custom data in and attach it to an existing component to enrich that topology with telemetry. And that's really what telemetry does. You have metrics, events, logs, and those three types of data, what they do is they are used to give health states to the components that are monitored. So this allows us to understand things like a particular component is in a deviating or critical state, but also what are the dependencies of those components? And if the dependencies are in a critical state, then that's ultimately going to affect the component that's interesting or relevant for us as well. And this is how it looks like when we attach tracing and telemetry data to the existing components. So tracing is the next one, where APM tools typically collect tracing. You've got open telemetry as well that is super rich and valuable for us to have this augmented type of information on our topology sets. And then the final variable is time. So as we build these topologies, what we're also doing is every time that something changes in an environment, and in the Kubernetes environment is a really good example of that, because you've got containers that last for seconds in some environments, but these seconds that they come up they could also cause damage, but then it's such an intermittent issue that it's really difficult to go back and troubleshoot it. So as we're collecting all of this data, every time we design a topology or we lay out a topology, we store a snapshot of it. And every time the topology changes, and that could be a new component coming up or being decommissioned, it could be that a health state changes for a component or a relationship, a dependency changes. Every time there's a single change in it, we then store a snapshot of that. So then we've got, and I'll show you that in the UI in the demo, we have the ability to then go back in time and see all of those snapshots. What is it that caused that change? So in this example, I can go back 2 hours ago and I can say, well, everything is green now. But 2 hours ago, I had a component that was in a critical state, and that originated my top level component to be in a deviating state. And this is really fundamental to understand not just how my environment is now, but which issues did I have, what was the impact of those issues, and what do I need to do to fix those issues. This is particularly valuable for site reliability engineers, for example, when they're trying to make sure that their environment is running in a healthy state and they can mitigate the risk of future issues as well. This is really how it looks like in the UI. We've got a topology at the center. So the topology data, as I mentioned, is captured from very different data sources, all of them pulling together a unified topology. We also then have tracing data and telemetry data that augment the topology by giving it health states. The telemetry data is also shown on the right-hand side. So this is where we highlight these golden signals that allow us to understand if we have any deviations. We also have things like autonomous anomaly detection that they'll scan through the data and using the artificial intelligence algorithms, they'll try to figure out if a particular metric is deviating or not, and they indicate that on the UI. And then finally, the time component is displayed at the bottom. So I have this timeline and I can see the overall state of the components in my dashboard. I can see that now, for example, they're red, and I can go back in time and see the events. As you can see the bottom lines there, the blue lines at the bottom. And I can go back in time and figure out what were the events that were triggered and what was the impact of those events as well. So with that, I'll move on to a demo. So as I mentioned, there's a series of out-of-the-box integrations that StackState has, and this is really the dashboard where we come and install these integrations. For today's context of this talk, Kubernetes is one of these integrations. So if I want to connect to Kubernetes environment, I click on the Kubernetes integration there, and I see that I've got a cluster being monitored. And the installation really couldn't be simpler. We've got a Helm chart that's used. So you run this command here, that one, and then eventually you connect to a StackState environment by passing the API key. So running these commands as a copy paste will install our agent set inside the Kubernetes environment and start to collect all of the data and the golden signals and so on. This also means that you don't have to instrument your application. You don't have to install agents in your container, container images, for example. You don't have to instrument applications, operating systems, nothing. You just run this, and this will install the StackState agent in the Kubernetes environment as a whole and start to collect data from that cluster. So in this case, we've got this cluster here. Let me just copy the name because we'll need this in a second. Together with this integration, we have not just the agent that collects data that's installed in the cluster, but we also have a series of dashboards. We have actions that I'll show you in a bit. We have golden signals and KPIs. So there's a series of things that are put together in each one of these integrations to make sure that you have value in the first minutes of utilizing StackState. So also to get this installed, it typically takes a few minutes, and that's it. So when I click on Explore the Data, I get taken to all of my dashboards, and I copy the name of my cluster, and I've got 4 out-of-the-box dashboards that are created for each cluster that I install the agents on in Kubernetes. So in this case, let's have a look at the namespace one. And I immediately get shown all of the namespaces that are in my Kubernetes cluster here. And I can see I've got an application, for example. I see I have specific things to make sure the application is running, like logging, tooling as well. I also have the StackState agents, which is the monitoring namespace here. And then I have things like webhooks, Kubernetes, cert manager, all of the components that ensure that my business application is running. I can also see on the timeline here that I'm now back in time that I had a critical issue, and this was a state of my namespace environment. So I've got an issue in my sock shop. So if I'm a site reliability engineer, really what I want is, as I said a while ago, I want to make sure that all of my applications are running, my business services are running, that everything is running as smooth as it can, but also that I don't have any business impact. So when I click on this, I can see also the actions out of the box that come with this integration. And when I click on this, what I have is I have isolated my namespace, and I want to figure out what's happening here. So at the moment, I've got a component, and this component represents a namespace. The component has two colors. It's got the gray color in the middle and the red color on the line around it. So the color in the middle means that there isn't any severity here. You can see the health state is unknown. It's a logical component, but my propagated health is critical. So what this means is, it means that my dependencies are in a critical state at the moment. So I could now start to go through the data and figure out where this is coming from, but I can also just ask StackState to show me the problematic areas here. So the sock shop environment is a very complex environment underneath, but if I click on the show full root cause tree, what this does is it's going to ask StackState, well, analyze all of the components that you have and figure out what are the relevant components for the particular issue that I'm troubleshooting here. And this then creates a map for me. Now, this map isn't a complete map of my environment. It's just a map of the sock shop namespace and the dependencies that are causing it to go red as well. So I can see, for example, that I've got straight lines between the sock shop and these components. So a straight line means a direct connection. But if I scroll down, I also have dotted lines. Now, as I mentioned, the environment is far more complex than we're seeing because StackState is abstracting that complexity from the viewer. So here I see that I've got a dotted line between, this is a process and a Java process on this side as well. So if I click on this line, I can see that actually the two processes are not speaking with each other directly. They're speaking via 1, 2, 3, 4, 6 other processes. But as I clicked on the show full root cause, StackState figured out that actually I don't need to show 6 additional components to understand what the root cause of the issue is here. So, and this is quite vital in terms of saving time to the SREs that are figuring out in very complex environments, are they having issues and where are the issues coming from? Now, the components that I've got here, they are taken out of the box from Kubernetes, but as I mentioned, I can create additional components here. I can create custom components that represent abstract things like business layers or business services as well. I can create components that represent full data centers and then create the dependencies between those components as well. So all of this is highly customizable. And also the type of component, you can see the middle icon here. So if I zoom in here, I've got a deployment that then belongs to a replica set. The replica set then has a pod that is running inside a container, and that container is running inside a process. So I can see all of the elements that I understand and they are familiar to me in my organization because these names are being picked up out of Kubernetes directly. Now, all of this data is being picked up by eBPF. So very easy to understand, lightweight to run as well. And it's capturing all of the components, all of the dependencies, and it's also capturing all of the golden signals as well that are relevant to me. So if I look at, for example, this component, the ingress, and I scroll down, I see a series of metrics here, a series of golden signals that help me understand just how well my ingress service is running. This is the service is represented here. I mentioned a while ago in the presentation, one of the things that we do is when we look at these metrics, we also have artificial intelligence algorithms that figure out if any of the metrics are deviating. And you can see on the right-hand side here, you've got these red lines. So this is issues that were picked up by our AI algorithms, and there are anomaly autonomous detection here as well. So figuring out now in my environment what's going wrong, I can see that my sock shop is having issues. I can see that there's a bunch of other components here. Now, this data here is, I'm now filtering on the data just for Kubernetes. So this is the Kubernetes agent, but this is running on an AWS environment. We then have an equivalent AWS agent running that's collecting data from AWS on everything that's running inside. So we're seeing a very small section of a very complex environment here. As I mentioned a while ago, when we then have several monitoring tools running at the same time, you end up having alert storms where each one of these tools will fire symptomatic alerts for the same underlying root cause. And what we do here is we bring these alerts together under one problem cluster. In this example, I see that I've got 3 issues here, and these 3 issues are being collated in one problem cluster. So then I would get only one alert out of this issue here. And I can see that my carts container is where these issues are coming from. All of these events are being captured as well. So StackState is also capturing all of the events that are passing in Kubernetes and all of the monitoring tools and so on. But if I click on this problem cluster, StackState then filters through all of the events and handpicks the ones that it believes that are the possible root causes for this issue here. Now, I see that I've got a bunch of properties changing. Now, I know that I may have changed a few properties, but that's typically not a big issue. But I didn't see that I have security group changes, and that's quite unusual because security groups aren't managed by this team. So this team would be managing just this Kubernetes cluster. So now if I'm a DevOps engineer and I'm looking at how do I figure this out? How do I figure out what's causing the soft shell problem? I click there. And then if I see the security group here, that shows me that a particular security group running in AWS had 1 addition and 13 deletions, yeah. So if I click on it, I see that I have connectivity to MongoDB. I have a user ID, a group ID, and this was removed from a security policy that's running in AWS. And here's the name of the security policy. So what this tells me is, well, I don't manage security policies, and this is coming from my carts container. If I expand that, it then shows me additional components. So let me group this by domain, because I really only care about my domain. So I have my Kubernetes domain here, and I see that on the side, I've got an AWS domain on the left-hand side. And I also see there's an EC2 instance there and a ton of components that depend on that. So the carts container actually needs to access the MongoDB. The connectivity for that MongoDB is being managed out of a security policy within this EC2 container. But the thing is, this EC2 container is in a whole different environment. It's running in AWS and it's managed by a different team. Not only that, but the EC2 instance here shows that everything is in a green state. So the health state that it's displaying means that everything is fine. So this team would not have seen any alert, whereas I'm receiving a ton of alerts here. So this allows me to understand my environment is actually okay. There wasn't any change in my environment that's causing this, but the AWS team that manages security policies has changed the security policy. So I can directly go to that team and ask them to roll back the change that they had where they removed access to the MongoDB. Now, this is brilliant for understanding that the issue is not coming from my environment. Which teams do I have to go to? But also, this gives enough information to the AWS team for them to understand exactly what they need to roll back in the end. So this is the main part of what I was hoping to show today. Any questions?
Yeah, so today, Ricardo, you've primarily focused on purpose on the Kubernetes environment with a wide variety of components. This is still a simplification, I would argue, right? Because in reality, the environments are way more complex. We abstract that away, as you've shown in a simple example. So that's really nice. But you also mentioned it's probably good for the audience. The purpose for today was focused on a cloud and container landscape. You mentioned that before, but probably good to repeat. There can be a ton of other type of components involved, right? And that doesn't matter for us. We're technology agnostic as such and can make up these pictures from all the way down infrastructure, data centers, rack, all the way up to customer facing business services or whatnot. So that's probably good for the audience to understand that and take that into account.
And that's a good point, right? Because so the environments that we're managing, even here in the STEM environment, they're very complex. So for example, if I expand the dependencies of this EC2 instance, we're going to see a ton of other components. And that's really the beauty. You see the number of components we have in this environment. Now, very quickly, in a few clicks, I went from having an overview of my namespaces to figuring out that a security policy on a whole different environment was having issues. And the environment that I saw, the components that I saw, thanks to StackState, are minimal in comparison to the real environment that's running underneath. So the ability to look at many dozens or hundreds of thousands of components and narrow it down into 10, 20, 30 components to root cause issues is really unique at this moment on the market.
Yeah. In particular, I can imagine, right? If there is an issue, if there's an outage, you go into the war room, right? All together, still digitally, but still you come together, right? And then figuring out by browsing through logs and individual dashboards, that's extremely hard. What we see our customers doing is they start here in the topology view, they pinpoint, right? They reduce where to look at, right? By 90%. All others can continue working. And just with the 10% that is left of the people or the teams, you can start focusing on this is it, and then quite quickly often narrow it down even further, as we've seen here today. Yeah,
absolutely.
Thanks.
And maybe another point, just another quick point to mention as well, that I have quite a lot of components on my screen right now, and it's incredibly quick to navigate this. And that's thanks to, so we built a proprietary topology, a graph database, sorry, to draw these topologies, so that it's precisely allowing us to have this flexibility and speed of navigating very complex dashboards and filtering out these components because of that database that we have.
Yeah, excellent. Thanks, Ricardo. Let me share my screen back again, if I do have the ability to do so.
I think you can go for it.
Yeah, there we go.
And thanks, Ricardo and Andreas, for an outstanding presentation. We'll go now to Q&A, and we have had actually a few questions come in over the chat. So first, with regard to who should own observability, what do you typically see there, Andreas? Where does that team typically reside?
That's actually a fantastic question. And I must admit, we did some real evidence or real research to that. And you really see the big three groups that take care of this are the IT operations teams. 40% of the organizations do that with the IT operations team. So the more traditional teams taking a look at the holistic landscapes, having already monitoring tools in place, they grow their profession and take more into account. Then the other one, the 30%, are the DevOps teams. So the observability shift left has been executed there successfully. So the DevOps teams take care of that. Often what I do know from my own personal experience is that starts really in the customer-facing applications. If you think about the online portals, the websites, the mobile banking apps, and these type of applications, and then more and more that drills to the core of the insurance company or the telco or the bank. And the last one we see coming up really big time are the platform teams. So central teams who are enabling developers with cloud tools, with development tools, but also with these type of practices. And that's another 12%. It's still small, but growing significantly in the last 1.5 to 2 years, I would say. So these are three options to pick and see where that fits.
Perfect. And of course, you're quoting from our research that we've just done with TechStrong Research, and we will have a whole report on observability on the StackState website in about another 2 weeks or so. So another great resource for people to learn more about observability. And Ricardo, did you want to make a comment as well?
So I'm just going through, I'm looking at the questions here. That's a really good question. So I'm starting bottom up. There's a question which is, what if the topology is wrong? That is, things are connected, but they shouldn't be, which is a really good question. So we have a bit of technology which we call 4T monitors, where you can write customized rules, and these rules you're almost coding really. So you have a lot of flexibility onto what type of logic you program. And these rules allow you to do things like check if a threshold in a KPI, in a metric was violated, for example, which is quite simple, but it allows you to do more complex things like, I see that I've got a host name, which has prod in the host name, that is dependent on a host name that has dev in the host name. So this shouldn't be connected. And that will then raise an alert. So you can write rules like this, generic rules that ensure that your topology is correct. And that's one of the main bits of functionality that, or one of the main purposes of that functionality, the 4T monitors.
Great. Thank you, Ricardo. Okay.
Let me know if that's the question, by the way. Sorry?
So I was just going to go on to the next question. So also coming in, is this cloud-based software that you manage from your cloud or an application that gets installed within my enterprise?
Yeah, and the answer is it can be both. So it depends a little bit on your situation. What is the data you handle? Is it a pure cloud environment? Then we see many of our customers choosing also for our cloud solution. But you can also imagine that you're running Kubernetes, but on your super restricted private cloud. And then we would recommend also that this solution lives on your recommended or on your private cloud. So it can be even air gapped. We have customers who do that. So you can still benefit from the holistic topology based observability, but in your own environment. And then there are a couple of flavors in between where some data resides on-prem and other data is coming from cloud sources and they're hosted in our SaaS solution. So it can really be a variety, but in essence, it doesn't matter much if you use the self-hosted version or the SaaS version.
Great, thank you, Andreas. All right, another question. How does it work if I have a private Kubernetes cluster and there are restricted outbound rules?
Yeah, I partially answered that. We have a customer or a few customers actually running really in a closed environment. So then the recommendation is, if that really is an air-gapped environment, to do the observability close by. So do that in that same cluster and run it there.
Okay, great. And here's a good one. When you showed the alert correlation, probable causes, what helps to do that correlation? Asset information or business flow?
So really what we're looking at there is the components that are involved in those alerts and the dependencies of it. So if we see that the component depends on the other and they're both having alerts, that is the first thing we look at. Then we look at the context of the alerts to bring them together under one problem cluster. If we have different monitoring tools that are triggering different alerts, and then triggering different alerts for the same component, that's another rule that means that those two belong in the same alert cluster or problem cluster.
Great. Okay. And then next question, what if the topology is wrong? Things are connected but shouldn't be. Can you ID that?
Yeah, we covered that one. That's the one about the 4T monitors where we've got the flexibility to create rules that check that the topology is correct.
Okay, awesome. Next question. Are there any measures or practices that StackState follows to see that there is not too much cost incurred for egress?
Yeah, that's actually a good question. We not necessarily focus ourselves on cloud cost monitoring, although there are a couple really good examples of our customers who spotted a lot of services that are extremely underutilized. So if your utilization stays extremely low, you might wonder, hey, do I need to re-architecture or reuse the machinery in a different way? So that's one way of looking at it. And another customer, when he started up StackState and started to ingest the data for the first time, and then StackState created the topology, they spotted that quite a bit of servers, it was more in the traditional area, but quite a bit of servers didn't have a single connection to any business applications. So that helped them tremendously to start cleaning up their data center and the physical racks and also the higher levels up in the stack to detect what wasn't used. So that's another way of looking at it. The other question that I partially see in your question, and I don't know if that is your question. So this is more on how you use StackState to improve the landscape from a cost perspective. The other one is about the footprint of StackState itself. Ricardo answered that by alluding to the eBPF framework that we're using. And if you're curious on how it's working, you can find a ton more information, but it's really a lightweight way to do so. And at the same time, also how we ingest the data into our system, understanding the data we need is a way to minimize that. So a little bit depending on what your question was, I hope that that answers it.
Awesome. All right, I think we have time for two more, and then we'll transition to some other resources that we can offer up. Is there a way for me to try out StackState? We love that question.
No, the answer is no. It's impossible to do. No, there's
We're only
obviously
demoing it.
I would say 3 ways to get familiar. One is the playground. The other one is a trial, but probably more important is to get a tailored demo to your needs, yeah, really see how it works. And all of it is on the website, and I think someone will post it in the chat as well.
Yes, exactly. You can email info@stackstate.com and we'll get you taken care of. And then last question, what is your best advice for someone starting observability on Kubernetes? We got a
Ricardo?
lot of good advice, challenges, and solutions today, but what's your best single piece of advice? And I want to ask this question of both of you.
I knew.
You can start, Andreas.
Okay. Yeah. So my first recommendation is to actually two, if that's okay. The first recommendation is to think in a different way on observability than you did before. So move away from the metrics, traces, and logs, and think about the topology way. And you've seen in the demo why that is, because it brings you so much understanding of how everything ties together. And in particular, if you move to serverless, we haven't touched upon that today, but it becomes even more difficult. So start with a topology in mind. And then the second thing is, one of my recommendations is start articulating goals. What is it that I want to measure? And then you need to answer the question more from a business perspective. What is it that I want to do for my end customer? And how does then that dribble down into what I'm actually starting to observe? So I would give this answer to to people who are new to Kubernetes and starting to use this and observe it.
Ricardo?
So when it comes to translate that, by the way, perfect answer, Andreas. It's a good intro for what I'm saying next. When it comes to translating that into the tool, then that's where having the ability to have custom components is fundamental, because those custom components allow you to map out business services, business applications at the higher level, and then start to track things like customer impact and business impact as well, which is fundamental. So, and topology is really at the core, because as I showed you a namespace, there's other parts that in our demos are not component, where we've got business applications and very quickly see that the business application is being impacted and where the impact is coming from. So all of those concepts that you're looking to understand how they're doing, and the goals, as Andreas is saying, all of that could be mapped out in StackState as well.
Great. Okay, I think that brings us to the end of our session. We do have some additional resources to offer up if you are interested in learning more, either about observability or StackState, and we hope you're interested in both. But we have 3 resources here. The first is a report from Gartner on innovation insight for observability. StackState makes Gartner research, select Gartner research available on our website. So that is one of the reports we're offering up. The second is, if you are interested in booking a demo, we have an online form that you can fill out and submit. And the third is a case study relating IT to business performance. So want to say thank you to our expert presenters for today's session, and thank you to everybody in the audience. We appreciate your time. Bye-bye, everybody.
Thanks, everybody.
Thanks for joining us.
Bye-bye.